So as I mentioned, this service we're seeing about 40 to in some cases 50% cost and time reduction. And that is to say that in a lot of cases, if we see a coordination process that's planned to happen for 4 weeks, it really starts to extend out into 8 weeks, sometimes 12, and sometimes even 16 weeks. One of the things about being a lean process company and so driven following the Six Sigma principles is that when we set that 4-week duration based on our management style and our project history, we're able to keep those durations and keep the coordination process from overrunning. And that's really important because a lot of times, as I mentioned, construction is chasing us. Coordination sometimes tends to be an afterthought. So by the time everybody gets on track with coordination, things are already being built, sleeves are getting set, inserts are in the deck, and it gets a lot harder to make changes. The way that we structure this whole approach to coordination is using a system that we've conceived at VICO called the System Priority Structure. And I'll show you exactly what that is a little further in the presentation. But it's basically a guideline that we first share with the entire project team at the kickoff meeting, and then we apply it to all of the decisions we make within the models as we proceed with clash avoidance and then clash documentation for unresolved issues. Another great byproduct to this service is that we do treat documentation very seriously. A lot of times coordination, you go to the meetings and there's a directive to fix a clash, but there's not necessarily a report that goes along with that to say which clashes were assigned to different parties, follow up to see if those clashes were resolved, and then again making sure that those changes are getting trickled down to the field installers who may need to know that we took this duct from within a corridor and had to locate it in the room, for example. We are also able to produce composite and trade-specific documentation. Composite drawings show all of the trades for the whole project on one drawing. We use color coding, abbreviations, symbols, all the stuff from standard construction drawings with a little bit of color and detail added to it. And those composite drawings help everyone to see the big picture. So that if you're out there on site and you're doing a deck walk or you need to make a change, we give you a document where you can see all the other systems that are in that area and you can understand the trickle effect of any changes you may want to make. Those composite drawings are then supported by trade-specific drawings, which I'll show you. We make them for the ductwork, the pipework, the sleeves, anything that you may need out there on site. And this whole process is not intended by any means to replace the work that the GCs and the subcontractors do, but instead we're trying to make them more efficient. Again, compounding clashes cause the coordination process to get pretty inefficient sometimes. So by internalizing and optimizing this process, we can make sure that the clashes that are being discussed on site are the very important ones that require everyone's attention, and so that they can remain engaged in the coordination process and they don't feel like they're working inefficiently. This process also integrates directly with our schedule and production control capabilities. Because we use standard naming and we use standard modeling elements, we're able to export a location-based schedule right from these 3D coordinated models. We can work with the project team to optimize that schedule and then do what's called production control on the schedule, so tracking actuals on a daily or a weekly basis for the construction process. All of that is, again, kind of a direct byproduct of the coordinated model that we produce. We've also got a build-to-design concept, so after we do this coordination work with the subs, we make sure that the work done in the virtual environment is the work getting installed out in the field. We won't have a chance to talk about that too much today, but perhaps that could be another webinar further down the line. And then again, the 6D, because of the standard naming conventions and the composite files, the only thing left to do at that point is just add the O&M and submittal information into the instance parameters of these coordinated models, and then you've got a deliverable that works for the installer and the end user, the building owner. So if we talk just a little bit about the existing coordination process, what's going on out there on site right now, one of the biggest problems is that the design liability and responsibility is a little bit ambiguous. Anyone who's read closely through a specification knows that the first paragraph you usually see in general conditions for each trade says something to the effect of all of this work still needs to be coordinated with all of the other trades. And that can get a little bit confusing when you're in a big coordination meeting and a decision needs to be made about who's going to move and whose responsibility it is to move. That can get pretty gray. And so we've come up with a good structure for addressing that. And we've also got a very powerful automated tool that helps us to address that. This liability is often transferred from the GCs to the subcontractors who buy out the project. So again, you have the specification statement that says everything needs to be coordinated with everything else, and it's assumed that all the subcontractors are going to be able to handle that on their own. Sometimes that works well, sometimes that doesn't work well. It really only takes 1 or 2 weak subcontractors to damage the entire coordination process for a project. So as that liability gets transferred, we need to make sure that it's really getting taken care of and addressed by the individual subs. There's a couple approaches to how subcontractors may be treating coordination right now. The direct approach is where subs have been through coordination enough. They know that it's painful, inefficient, and can go on for months and months and months. So they build that into their bid. They put a high price up front, knowing that they're going to have to participate in coordination and that it could go on for an extended period of time. So when they submit a bid to an owner, there's a pretty good chunk of change in there for them to handle that coordination process. There's also an indirect approach where subcontractors may be aware that coordination needs to happen, but they don't necessarily put it in their bid price, and then they expect to recapture those costs through change orders during the coordination process. Again, kind of relating to those compound clashes, the change orders can start to spiral out of control when one fix you make causes another clash further down the line. We've also noticed that there's not a lot of science to the pricing that's going on. So even in the direct approach, when subs are able to put a number in there for coordination, sometimes it's not entirely clear where that price has come from. We had a little bit of a joke when I worked in the field that we would just weigh the drawings and see how much they weighed before we put a price on there for coordination. So in VICO, we've come up with a very powerful calculator that works on a square foot basis, a complexity basis, and level of detail to make sure that the pricing and the solution for the coordination we provide matches the project needs. And then, as I mentioned earlier, there are some liabilities with or lack of accountability with the traditional coordination approach. So one weak participant can make it a bad process for everyone, and through our approach we think we've started to address that situation.